We have practiced solving lines. We have practiced solving square roots or equations that have square roots in them. We have practiced solving quadratics. We have practiced solving equations that even have variables in denominators. So last but not least, to kind of wrap up the last bit of chapter 1, what we want to do is practice solving inequalities. And the difference between inequalities and everything else is just the symbol. Instead of having all these equal signs, we have our inequality signs. And our inequalities are just the less thans, the greater thans, less than or equal to, and greater than or equal to. And this is a great way to wrap up this section because, oh, it's so much nice. Y'all have had practice with this. I think it's just a matter of scraping away those cobwebs and you're going to get right into this really fast. And the key, whenever you want, it's just like solving a regular linear equation, what we started out with in 1.6. The only difference is that when you get to the point where you have to maybe divide off that coefficient in front of your x term, if that coefficient is a negative number, you have to reverse the direction right here. Reverse the direction of your inequality sign. Okay? And then other than that, you have one little thing is you have to write your answer in just a special way. But other than that, it's just like solving a regular linear equation. So let's get started real quick into example number 13. I want to solve, if I gave you instead negative 6 is equal to 4 plus 5x. This is what we're used to seeing from back in 1.6. You're like, oh, that's no problem. Let's move that 4 over, make that negative 10, and then let's divide off that coefficient, and we got our answer. Well, hey, guess what? We can do the exact same thing here. All the same rules apply. We want to isolate the x all by itself, so let's move the 4 across. If I subtract 4 from both sides, you'll get negative 10 is greater than 5x. Now I can do that. You're like, wait, I just moved a minus across. Let's go back to that definition. It says the key is if you ever multiply or divide both sides by a negative number. So if you ever multiply or divide, not add or subtract, just multiply or divide by a negative, then we reverse the sign. So we're still good right here. And then right here, again, to get x by itself, I'm dividing by 5. It's a positive 5, no worries. So this is saying negative 1/2 is greater than x. Okay, now interpreting inequalities is a little weird. This is saying negative 1/2 is larger than x. So I want to see all the numbers to where negative 1/2 is larger than that. Or think about it the other way around. You see how, like y'all all remember alligator things? You see how it's pointing towards the x? What if we read it more like this? They're the exact same thing, but sometimes it's easier to read it when your variable's on the left side. So it's all the values of x that are less than negative 1/2. So negative 1, negative 2, negative 3, all the more larger negative numbers are definitely smaller than negative 1/2. So there's part 1 of my answer. How to do part 2 of my answer is I have to list this in interval notation. So to help me out with interval notation, I'm going to use a number line to help draw myself a picture. Let's put negative 1/2 on here. And what I want to do is shade the side that would talk about everything being smaller than negative 1/2. So smaller to the left or to the right? Well, obviously it's going to come back this direction. So those are all those values smaller than 1/2. If we can say 0 is right there. Okay, so when we talk about this, how we're going to do interval notation is always, it's like a bound. In this interval from this number to this number are all my solutions. So how far left does that shading go? Well, it's going to go forever in the negatives, right? So it's going off to negative infinity. Well, how far right does that shading go? It goes up to negative 1/2. Notice I put parentheses here. We're going to come back to this whole concept here in just a second. But this is the interval of where all my solutions are. As long as I pick a number somewhere between negative infinity and negative 1/2, it's going to solve this thing right here of being smaller than negative 1/2. So there's part 2. There's me giving my answer in interval notation. Okay? Okay, and like I said, let me come back to this whole part of this parentheses thing. If your inequality had less than or greater than, you always are going to use parentheses when you're doing your interval notation. If you have less than or equal to or greater than or equal to, what we're going to use are brackets. Wow, I totally misspelled that word. Brackets, no, brackets. And always, as a rule of thumb, with your infinity sign, so negative infinity and positive infinity, you use parentheses. because parentheses mean we can't exactly equal it. We're just going right up to it but not equaling it. Brackets say we can equal it. And since infinity is, something like, give me the largest number you can think of. I can think of one higher than that. We can never equal it because there's no known value. So we're always going to use in parentheses with the infinity signs. Okay. And with interval notation, for some of you guys that haven't really been exposed to it very much, it's always the smallest number, then comma the largest number. So there is definitely an order you have to give this in, and it's either going to be a parentheses or a bracket. A parentheses or a bracket, depending on your context. But like over here on the left, when we were saying all those values of x that were smaller than -1/2, we always go left to right because left is always the smallest and right would always give you the largest. Okay. All right, let's take all of these concepts again. Let's go to the example number 14. Here in example 14, we have two inequality symbols going on. We have a less than or equal to and just a less than. And I have my variable right here in the middle. Anytime you have multiple inequality signs within it, your goal is to isolate the variable again as normal, but we're going to keep it just in the middle by itself. So let's just focus here in the middle. What's the first thing you would probably want to get rid of? Well, you're like, oh, I would subtract the 4. The only difference here is we got to do it to 3 parts. The left side, the right side, and the middle side. That's the only difference here. We're still going to isolate that variable, just going to isolate in the middle, kind of sandwiched in there. So -12 minus 4 is a -16. And I have the -2x left in the middle. And then 6 minus 4 is 2. Okay, right here, to keep getting x by itself, I'm going to divide off that coefficient. And like I did with the 4, I've got to do it with all 3 parts. And we are going to put ourselves a wonderful star to watch out, because look what's happening here. I'm dividing by a negative number. And anytime you divide by a negative, then I have got to flip those signs around. So it's saying 8 is now greater than or equal to x, which is greater than -1. Or if I always want to list this smaller to larger. So you see how it's pointing towards the -1? Still pointing towards it. Pointing towards the x, still pointing towards the x. There's the exact same thing. And it's just a little easier to read when it's in this form. So here's part 1 of the answer. And if we want to go to part 2 of the answer, let's graph this on the number line to help me figure out the shading. Here's -1 and here's 8. Okay, so I want to know all of these solutions, all these potential numbers that have to be larger than -1. So it's got to be to the right of -1, but smaller than or equal to 8. So smaller than or equal to 8. So it's all this stuff in between. At -1, I can't equal it, so I want to use a parentheses. At 8, I can't equal it, so I can use a bracket. And there's my interval notation. So this into interval notation, the smallest value is -1, the largest value is 8, and there's part 2 of my answer. So together, those would be my answers for this whole problem. Okay, so hopefully this is making just a little bit more sense. Let's go on to example number 15. We've got 2 parts here. It's saying x plus 1 is greater than 4, or x plus 2 is less than 1, -1. Let's just work on both sides together. So x, if I move the 1 over, is greater than, by subtracting, so it'd be 3, or x, if I subtract the 2, is less than -3. Okay, so there's technically the solutions. Not too hard. You're like, well, what was the big deal with that one? Well, let's go to the the shading. We got to talk about this. Here's -3 and here's 3. The first part saying I want all those values that are larger than 3. Can't equal it, so I'm going to do parentheses, and larger is obviously going off to the right. Okay, I want all those values smaller than -3. Anything smaller than -3 means it has to be more into the negatives, so it's going off this direction. Okay, so how are we going to put that in interval notation? I've got this gap going on. Like before, always go smallest to largest. So we're going to start on this left part. How far left is that shading going off? Well, it's going off to -infinity, and then it comes up to right at -3. Can't equal either one of them, so I'm just going to do parentheses. Let's go to the second part. How far left does that shading go? Well, it goes to 3, and then how far right does that go? Well, it's going off to the higher in the positives, so it's going off to +infinity. And what we do is how we connect this, because what we're saying is I can get all those solutions either coming from here in this interval or from here. In the world of math, if you put this U in here, that stands for OR. If I don't want to write the word OR, then all I have to do is put that little U in there, and that means OR. So written out with inequalities, the answer is x is greater than 3 or x is less than negative 3. Written out in interval notation, it's saying all my answers have to be between negative 3 and negative infinity and negative 3 or 3 to positive infinity. The exact same thing. Okay, so going to example number 16. I want to solve two things simultaneously again, this time connected with an AND. So let's move the 4 over. And x is less than or equal to 5. Let's move the 3 over, and x is greater than negative 1. Okay, so boxing those up, that's part 1 of our solution. Let's go to our number line to figure out part 2 of this. Okay, so here is negative 1, and here's 5. It says for x to be less than or equal to 5. So I can actually equal 5, but I have to include everything less than that, going all the way down that way. Okay. Now this part says I want all those values that are larger than negative 1. X has to be, so all those numbers that are bigger than negative 1, not including it. So I'm going to start here at negative 1, and this time I'm going everywhere this direction. Well, your answer with AND has to be the overlapping area. What in that interval, what kind of interval can you create where the two shadings overlap each other? Well, hopefully you'll see that the farthest left that overlapping, it's going to be all right in here. So the farthest left is negative 1, and the farthest right is positive 5, but equaling it. So there's the answer in interval notation. Okay, it's where we can get answers that are both less than 5 and still larger than 1, or negative 1. And that's the interval that describes that.